In this video, we're going to take a look at Intigriti's June XSS challenge that was created by Godson. We run these challenges once a month and they last for a week, and at the end of that week we draw 6 winners who will get a €50 swag voucher. 3 of those are randomly drawn from the correct submissions, 3 are for the best write-ups, and then the challenge creator will also get a voucher. We release a hint for every 100 likes on the tweet that we put out, and we encourage you to join the Discord community if you want to discuss the challenge, ensuring there are no spoilers in the process. We do get a lot of questions about the write-up submissions, so let me just try and clear that up. Once the challenge is over, we select the 3 best write-ups and we want to be able to share them on social media. If we don't have a link to the write-up, we're not able to share it. But we don't want you to publicize the write-up before the challenge ends, so the best thing to do is add a link to the report with a private GitHub gist, or you can use like hackmd.io, or use a private Medium article, or you could just send it through as a PDF or a markup document, and then give a link which will be public by the time the challenge ends. We're currently 5 days into the challenge, and I've received 5 write-ups, and there are 3 different solutions, so I'm going to run through the intended solution, and then we'll take a look at the 2 unintended solutions that I've seen. And then if anybody found any other unintended, you can let us know in the comments. In terms of the requirements for this challenge, it should work on the latest version of Chrome. The goal is to execute alert document.cookie, and as usual with the XSS challenges, it shouldn't be self-XSS or related to man in the middle. In other words, don't submit a report saying open up console and type in alert document.cookie. You should be able to provide a URL which I can just click, and that's what pops the alert. And you submit that solution through this link here, and yeah, it should require no user interaction. Now it says it should work on the latest version of Chrome because it doesn't work with Firefox by default. However, you can go to About Config in Firefox and enable the sanitizer. Go in here and search sanitizer, and you have DOM security sanitizer enabled. It's set to false. If you set that to true, this will allow the payloads to work in Firefox, which is good for me because I'm in Pirate OS and I don't have Chrome installed. I have Firefox and Chromium didn't seem to work with the payloads either. So with that stuff out of the way, let's go and take a look at the challenge. We can scroll down and find that we've got an iframe embedded in the page, but we want to actually go to the challenge page directly. And we just simply have this text box saying enter in your name and click submit. So the first thing we might do is just try some normal input. What if we just type in hi and click submit, and we get this pop up, it says hi, and we notice that we've got this get parameter at the top of the page which now has hi assigned to it. Alright, well what if we try and put in here a h1 tag and do that again. Let's see if we can just inject some HTML. We do that and it doesn't appear to be any different. Let's try that again with a bold tag. So that works. So we could try an XSS attack. It's not likely to work. That would be quite an easy challenge, but let's just see what happens if we set an image source to X, so something that's invalid, which is going to trigger an error, and then whenever that error occurs, we want to say alerts. And we can do that. We can click submit. We get our pop-up window, but that's not an alert, so we've just got an invalid image here. It failed to load it, but it didn't actually give us that alert. So the next thing we might do is use Control and U to open up the source and go and have a look through this. We've got some JavaScript in here and it doesn't have any syntax highlighting, so that's not very nice. We could either open it with the developer tools and have a look at sources so we get that syntax highlighting, or you can just open it up with an IDE of your choice. I'm going to open it up with code. So we'll do code and we'll do index.html and then just paste this in. Now we get some nice syntax highlighting on the HTML and the JavaScript. So let's go up to the top. So the first thing we see here are some dependencies which are imported. We've got jQuery 2.2.4 and jQuery deparam. If we Google jQuery 2.2.4, we'll get back an article saying this was released in 2016. We can also scroll down a little bit and see do we have any vulnerabilities. I did actually try to use a sneak code checker, which is often quite good in these scenarios, but even with the full HTML, it didn't seem to pick up the fact that this was a vulnerable jQuery, and said that the code was secure. I also checked ChatGPT as well, and equally disappointed, unfortunately. But yeah, we've got a few vulnerabilities here. We can see cross-site scripting is mentioned a couple of times. We can also see prototype pollution is mentioned as well. So there's some things that we might want to look into once we've taken a look at the rest of the code. We also had jquery deparam as well, so maybe we'll search jquery deparam vuln and see do we have any vulnerabilities, and we do that, we come back with another sneak article saying there is prototype pollution, and we also have a GitHub link below that which has some gadgets. So if we open up the GitHub link, in here we've got an example of vulnerable code fragments, and we've got a POC here as well, so maybe this will be interesting, but all we've done so far is found that we've got some out-of-date libraries that do have vulnerabilities. We need to actually see what the code is doing with these libraries. So the styling's not likely to be of interest to us. Let's go down towards JavaScript. So we have a comment here which says, reCAPTCHA is still under development. Soon it'll be implemented on the live site. Anytime you see a comment like this in a CTF challenge, there's a good chance that it's important. So we'll come back to that later. In terms of what the code is doing, it's checking if the domain is the Intigriti domain, which we've run the challenge on. It will set the window.recaptcha to false, otherwise it'll set it to true. Actually, not otherwise, because it's not an if-else statement. So if it's the Intigriti domain, it'll set it to false. If it's localhost, it'll set it to true. That's worth bearing in mind. After that, it'll set window.name to null, and then it's going to set the parameters to deparam of location search.slice1. Let's go back to our challenge page and let's open up our developer tools, paste that in, and we'll see that location.search.slice1 is simply the first parameter, the get parameter that's provided in the URL. Now, you might be thinking, where did I hear deparam recently? Well, we heard it a minute ago when we looked at the jQuery deparam vulnerability around prototype pollution. And if we actually have a look at the POC, interestingly, the code that we have in our challenge is exactly the same as this vulnerable POC. After that, we've got handle submit. So this is just a function which is basically going to deal with us clicking on submit. We don't really need to worry about that. And a function to close the modal, again, not of interest. Down here, we have an event listener. And this is making use of that window.recaptcha that we saw at the beginning. So when the DOM content is loaded, it's going to set name to be equal to window.params.name, which was what was just assigned with that deparam function call. We have some more stuff here just around the styling, depending on whether things are assigned or not. And then another comment, reCAPTCHA is still under development. So anytime a CTF challenge creator says that something is under development, what they mean is I haven't had time to test for bugs yet. So there's probably a bug around here somewhere. It is checking if window.recaptcha is set to true, and if it is, it's going to create a new script which is basically going to be the reCAPTCHA API, and it's going to append that to the document. After that, we've got a try catch, which is simply going to try and set a HTML to be the name that we provide, but it's running that through this sanitizer. So you can see it's creating a new sanitizer with a comment saying that this will prevent XSS. So it can be a good idea to break challenges that have multiple components down. And the first thing that we noticed in this script is that if the challenge is set to the Intigriti domain, window.recaptcha is going to be set to false, which means that we're not actually going to get through to this section of code. And that means if there's a vulnerability in here, we're not going to find it because it's just never going to be triggered. So we could first of all try and find, is there a vulnerability in the process here where this has been assigned and we can somehow bypass this and have it set to true. However, maybe it's just a good idea just to use localhost to begin with and have this set to true, and then if we get everything working, we can cross this bridge when we come to it. So let's go back to the challenge page and let us go back to our console. And if we check now, window.recaptcha is set to false, and it should be because the domain is equal to the Intigriti domain, which, as we saw in this statement, is set in window.recaptcha to false. So let's save this. Let me save the page. Save as, I'm going to save it to the desktop, challenge, save. All right, and then let's see what we've got here. We've got the files, so that is going to have our jQuery libraries in it. And now we can just do, well, you can use like a Python simple HTTP server. I've got an alias to do that, so I'm going to show that. Type -a web up, and then I'm just going to run it. That's going to create this little HTTP server. So if we now go to localhost, I'll take a copy of this because we're going to want to go back to that page later. Let's go HTTP localhost and change this to xss.html. There we go, that looks good. Let's open up our developer tools and check if window.recaptcha is true, which it is. So that means that this part of the code is now being triggered and it's loading the reCAPTCHA. Another bridge that we'll cross when we get to it. Let's have a look first of all. We're just going through this in order. So we skipped this part. We're going to save that till later. But the next part was this deparam call. So let's go and have a look at our vulnerability again. We go back to our proof of concept, and the proof of concept says if you have this in the code, then try and do this. So let's try and do it. I'll go up to the address bar, get rid of this name parameter, and let's change the parameter to be proto, and then pick a value here. So I'm going to put this as cat, and then give it a value. Hit enter, we refresh the page, and in terms of what prototype pollution is, it's essentially a vulnerability that allows attackers to add arbitrary properties to global object prototypes, which then may be inherited by user-defined objects. So because we've just now polluted that prototype, if we type in object.prototype, and look what's coming up already. Let's do cat, there we go. So it's got cat and it has that value. Now the thing is, everything in JavaScript is an object. So if we now try and look at documents, dot cat, that's also set to 420. And what about window.cat? Yep, and what about cat? There we go. So now every object has this property, and it's basically because we have polluted that prototype, right? So every other object will inherit whatever properties are in this object, and we've basically said that this object has this property of cat, which will be set to 420. Oh, by the way, if you didn't find this, if you didn't find the link that we got there with that proof of concept, this formed the first and the second hint really. So the first hint was pollute the planet, and the second hint was about outdated dependencies. So both were a hint to go and look at jQuery and jQuery deparam and have a look to see if there are any prototype pollution vulnerabilities. Okay, so we found and exploited the prototype pollution vulnerability, but where's the XSS? Well, this brings us on to the reCAPTCHA part, and I thought it was a nice quote in Rick's writeup. He said he got some advice recently that if a challenge contains something weird and unnecessary, it's probably weird and necessary. And that's a great example. In this case, we have this weird captcha being included, and we've got some comments around it being under development and things like that. So it's weird that it's there, but if it's weird, it's probably there for a reason. Now, like the jQuery and deparam libraries, we could do some Googling around this and try and find some vulnerabilities with reCAPTCHA. And if we do that, we'll actually come across the same link that we found the jQuery deparam POC on. In here we have gadgets. So there are various gadgets, and one of the gadgets is recaptcha.md. So a gadget is basically a piece of code that behaves differently once we pollute object.prototype, which we've found out how to do. And the example here shows us how that we can turn prototype pollution into cross-site scripting using reCAPTCHA. So here's the payload, and here's the requirements. In order to use this payload, we need to have the script looking something like this. So we need to pollute the source doc and pollute that with the JavaScript. Let's go back. Let's add this in here, change that to an and because it's the second parameter. It reloaded and we didn't get any XSS. What happens here if we have a look at the source doc? We have a look at it and it does have our script alert1/script in it. The next problem is that we are missing this div. So you have this div class g-recaptcha, which is also required in order for this proof of concept to work. Well, we can also set this. So let's go back and I'm going to copy and paste this payload. So here we have our source doc. It's still set to do that alert, but we've changed the name to be this div class because we know the name is going to be inserted using that set HTML. So we can do that, reload, and we get an error saying missing required parameters, sitekey. So we see another problem, the problem being that we need this data-sitekey to insert into the div. We could try and insert this. I'm copying this over again because we want to URL encode some of this and it's just a bit harder to manually type it in. But it's the same thing again. We're doing our source doc, sets that alert. We set our name to be this div class with g-recaptcha. The only difference is we're now adding in the data-sitekey. So we don't get what we're hoping for. And if we go back to the inspector and have a look for reCAPTCHA. Oh, why is this a hard word for me to type? reCAPTCHA. Okay, we've got the script has been imported. we have it mentioned down here. What I should be looking for here is g-recaptcha, because that'll stop all these false positives. But there's no results. What if we go back to the last result we had? And now we do have it. So as soon as we tried to insert that site key, it just failed to insert the div whatsoever. And this brings us on to another important point. If you look at the new sanitizer that's created, notice that it's not new sanitizer with open brackets. It's new sanitizer, open brackets, and then curly braces inside of that. And essentially what this does is it creates a new sanitizer with a default configuration or empty configuration, which is going to be set to the default. And we can't actually open this up in Firefox, or I couldn't get this working anyway. Let me try it again. If I do here, new sanitizer, and then brackets, and then curly braces, enter. Oh, hit enter, and it pops up. We can have a look through the details. However, it doesn't have the function that we're interested in, which is the getConfig function. I'm not too sure why this is. Maybe it's just due to the experimental sanitizer in Firefox. Remember, we had to enable that at the beginning to make any of this work at all. So I'm going to go over to Chrome just to demonstrate this part. Okay, I'm over in Chrome and I'm going to do new sanitizer, and then we're just going to put in these empty braces again for the default config. And now if we click on it, we should see that we've got this function getConfiguration, which we didn't have before. So let me create x equals new sanitizer. We'll give it that default config, and then we'll do x.getConfiguration. That's going to return all of the configuration here. And if we have a look through the allowed elements, where's the array? We can have a look through all of this. Basically, we don't have that data site key, which is what we're trying to insert. So that's going to be an issue for us. The problem is the config, and we've also got allow unknown markup is set to false. However, what is this? This is an object, because everything's an object, and we have a prototype pollution vulnerability where we can pollute objects with properties that we want. So why don't we just change these properties to be allow markup is true, and then insert allowed elements like our data site key. Now, I did see a couple of ways to do this based on the solutions that were sent through, but essentially we want to allow unknown markup, and we also want to allow the attributes for class and the data site key. Here's one example of a payload that somebody sent through. So we set the data-site key to be allowed, same with the class, and then we allow unknown markup. We are polluting the srcdoc, which is the g-recaptcha gadget that we found, and that's got our XSS in it. And then the name, which has been inserted into the HTML, is going to insert that div with the class g-recaptcha and the data site key. And this can just be anything. It doesn't matter. As long as we're able to meet these conditions where we have a div with that name and we have a data site key value in it, then that's enough for us to pollute the srcdoc and for it to execute. So let's go back. Let me take a copy of this code. We can paste this in here. And we get this alert, flag is equal to flag XSS, and that's us. We have popped the alert with document.cookie. So you can send this link to somebody and this will pop the alert. However, it's on localhost. So what's going to happen now when we take a copy of this and go and paste it in to our challenge page? Let me paste the parameters in here. Does that all look good? It does. We hit enter and we don't get an alert. So we have things working locally but not remotely. Why might that be? Well, what did we say we were going to leave till the end? It was this part of code at the beginning, which says if the domain is challenge-0623.intigriti.io, window.recaptcha will be set to false. If window.recaptcha is set to false, how are we going to exploit it to turn our prototype pollution into XSS? The answer is we can't, not with this technique anyway. We'll have a look at some of the unintended solutions after this. But as I mentioned at the beginning, this is a bit of a weird statement because instead of it saying if the domain is Intigriti.io, set it to false, else set it to true, it's an if statement. So if neither of these conditions are true, window.recaptcha will never be set. And if window.recaptcha is never set, that means we can pollute it. So there is an interesting bypass for this one. I've opened up an article here which is quite long, so I'll not go through it in detail, but essentially, fully qualified domain names actually end with a dot, even though we don't provide that dot in the URL. This article explains why that is and how different tools respond differently, what the reasons are for including that as the actual top-level domain. But I'll not go through that in full detail. If you want to research that in your own time, you can. All we need to know here is that if we add a dot to the end of this domain, it will not technically match this domain, which means it won't be set to false, but we need it to be set to true. So at that point, we'll need to also do some pollution. So if I do F12 now and do window.recaptcha, it's set to false. If we add a dot into the domain, I don't think it's actually going to work. Let me turn off burp. I think this caused some problems earlier. Do that again. There we go, that loads. And now if we check window.recaptcha, it is undefined. Awesome. So let's define it. All we need to do is just go and add this into our payload. I could have really added this parameter anyway. I don't know why I'm waiting until it gets to the end, but let's just do it. Proto, and then we set recaptcha is equal to 1 or is equal to true, and then we get our alert again. And that's how we can solve it. This is the intended solution. So just a recap of what we did there. We used prototype pollution, which we found that vulnerability in the deparam library of jQuery. We used a gadget in Google's reCAPTCHA to turn that into an XSS. However, we also had to pollute the sanitizer config to make sure that we were able to meet the requirements of that Google reCAPTCHA gadget. And then finally, to bypass that domain check, we also polluted the reCAPTCHA value to set that to true. Oh, by the way, the reason that didn't affect the cookie is because the document.cookie is set whenever the page is loaded. So if it was set by the server, then changing the domain would be an issue because we wouldn't be able to access the cookie for that other domain, even though it is actually the same domain, but the domain name differs. And it'll work okay because this is actually set at the beginning. So if we load it with a dot at the end, the cookie will have that. Let's actually go into our cookies, storage, cookies, and we have here, let me expand, can't see the domain. There we go. All right, so it has a dot at the end. If we load it without the dot, then it doesn't have the dot at the end. So that's an important factor which allows this challenge to work as intended. Okay, now on to the first unintended. This is actually my favorite way to solve the challenge. Let me paste this into the console so we can talk through it. This allows us to bypass that sanitizer config altogether. So the reason we had to use that sanitizer config or get around the issues with the sanitizer config is because we wanted to inject the data site key or however it was, and we weren't able to put that value into a div. We had to allow unsafe markup, whatever. We had to specify that that data site key could be used. However, we can actually pollute the site key parameter at a high level as well. So at the prototype object level, we can actually just change site key. Notice this is site key, not data-site key. And basically the data-site key that we set would later be used as the site key, and we're just polluting that manually. It doesn't matter what it's set to. And it means that we don't need to do anything around the config. So we're simply using the srcdoc pollution to inject the scripts and making sure that we have the g-recaptcha div in place. If I take a copy of this and go up to our address bar, paste that in, you'll see that we also get the flag in an alert. Onto the unintended solution number 2, we can go back to the GitHub page, which actually has the solution on it as well for this. If we go into gadgets, and this time instead of the reCAPTCHA, we're looking at jQuery. And this tells us some proof of concepts. It has this one. This one at the beginning is x.off jQuery all versions can be exploited through string.prototype. And it gives us an example that we can use here with document.domain. And let us try it. I think as far as I remember, we can just copy and paste this in. Let's go back, set that to document.cookie. And actually, let's take this dot out of the domain as well. Enter, and there's our flag. So this one bypassed everything really. It bypassed the domain check, we don't need the dot at the end, and it also bypassed the requirement for us to use reCAPTCHA. So reCAPTCHA isn't used at all in that payload. Let me actually take a copy of this with some indentation so that you can see what's going on a little bit better. Yeah, so we just copied and pasted that directly. There is nothing here around reCAPTCHA. There's nothing here with srcdoc. And there is nothing here for bypassing the domain check because the domain check doesn't matter for this one. Oh, and in terms of the actual vulnerable code here, if we go back to the POC, this is it. So .off jQuery all versions, and then we have an example down here, document.off foobar. Well, if we have a look at the code that came with the challenge, the dependency, and go down to line 3541 in the jQuery 2.2.4, we'll see that we actually have that jQuery document.auth and then ready. So this is the vulnerable code in jQuery, which means that that attack will work. Okay, just a final recap then of these three solutions. We have our intended solution at the beginning, which featured prototype pollution with the jQuery deparam, and then we escalated that to an XSS using the Google reCAPTCHA gadget. And in order to specify the values that we needed to use that gadget, like the data site key in the div, we had to pollute the sanitizer config to allow these attributes and also to allow unknown markup. We also had to bypass the domain check by adding a dot to the end of the domain, and then we polluted the reCAPTCHA to true. The second solution also used reCAPTCHA, polluted that to true as well, and used that domain bypass. However, it didn't rely on polluting the config for the sanitizer because we were just able to pollute the site key on the prototype level so that we didn't actually need that data-site key, because the only reason that's being populated there is in order to populate site key. And finally, the third solution bypassed the need for Google reCAPTCHA altogether and that srcdoc exploitation. It didn't need a domain check bypass or changing sanitizer config or anything like that. It simply required copying and pasting the script gadget from the jQuery gadget section on the GitHub link that we were looking at. Anyway, that's going to wrap it up for this video. I hope you've enjoyed it. It has been quite a long one, but there was quite a lot to get through, and hopefully I explained everything okay. Thanks to Godson for creating the challenge, and big thanks to everybody who submitted a write-up, particularly those who submitted them early in the week, as they helped me make this video. And if you found a solution which wasn't covered here, we'd definitely be interested to hear that. You can leave a comment down below, and check out some of the community-supplied write-ups, which will be linked on our Twitter as well. And anyway, hope you've enjoyed this video. Any questions or comments, as ever, leave them down below. Thanks.